We will examine two cases side by side, one that has all acute angles and another that has an obtuse angle. The key to this proof is to place the vertex A at the top of the triangle and form two right triangles by drawing the altitude AQ. Notice the right triangles that have been formed. Since the law of cosines is a modified version of the Pythagorean theorem, it shouldn't surprise you that we use the Pythagorean theorem on each of these right triangles. We can simplify this equation by first squaring the binomial, and then distributing the sign, and finally moving all but the c² term to the right side. Before continuing, let's make some room by compressing a few steps. We have almost arrived at the law of cosines, except for the term v, which is not an entire part of the starting triangle. However, from the right triangle ACQ, we can form an expression for the length of v. Since the cosine of c is equal to the adjacent leg v over the hypotenuse b, it follows that v is equal to b times the cosine of c. By eliminating v, we have an expression that uses only measurements taken from the original triangle, and we have arrived at the law of cosines for any triangle containing only acute angles. The other forms of the law of cosines can be derived in a similar way by drawing altitudes from the other vertices. If one angle is obtuse, the proof is very similar. We again use the Pythagorean theorem on the two right triangles formed by the altitude AQ. The remainder of the proof is summarized here. It is very similar to the proof that we just finished. Study the steps carefully. Again, the other forms of the law of cosines can be derived by drawing altitudes from the other vertices and going through the same process. Knowing the measures of two sides and the angle between them is a good hint to use the law of cosines. Notice that you use the cosine of the angle opposite the side you are trying to find. Here are the remaining steps of the solution for you to study. Notice that the cosine of 100 degrees is negative because it is an obtuse angle.